COVID-19
My dear students, this is my 13th video of engineering thermodynamics and will be discussed about steady flow energy equation. As already we have discussed what is flow process and steady flow devices. Everything was discussed. Now we are going to link the flow process and in specific steady flow process, and also we are going to form the equation, that is energy equation for the above said cases. Okay, now before entering into the various energies that can be accompanied by an open system, let me revise the last video inputs that open systems are nothing but they are allowing both mass transfer and energy transfer in or out of the system, and steady flow process means the state parameters or state properties or study or and remain same constant with respect to time. They will be changing by position but will not be with respect to time. Okay, so dou p by dou t is always equal to 0. P meant for any properties. And another more important definition is flow energy. Why here flow energy is involved in this study processes is, in the flow processes we have to make the flow of the working substance from one place to another place, for which we have to supply our own power or energy for the movement of the fluid. Okay, so essentially flow work represents the flow required either to push or a certain quantity of fluid or in or out of the passage against the existing pressure. Always if you want to make the movement, so you would have seen in so many places and the home appliances, the compressor would be a part of all the equipment, which is nothing but the purpose is to make the flow of the working fluid in all the equipment. Compressor is a power consuming one, which you know very well, right? So without compressor, the devices or especially the thermal devices will not work, because the fluid substances or matters are moved by the power consumption of the compressor only. Okay, so now another one more important thing is the flow work is expressed in terms of property of the system, and it is also taken as one of the energy which is we are giving input, and as well as in the outlet also we are taking the same flow energy consumption for letting the substance to go out of the system. So in both inlet and outlet we have to add the flow energies which we are spending against the pressure or the resistance for the movement of the fluid. Okay, so now the flow process as accumulation, the flow process is characterized by no change in mass of the fluid at the inlet as well as in the outlet, that is around the control volume, and the fluid is uniform in its state. It will not change with respect to time, and of course can be with respect to position, and heat and the work interactions at the control surface is possible, and all types of mass transfer is also possible through the passage load. And finally we can tell the flow is unsteady if the parameters or the state properties are changing with respect to time. Okay, so now let me start the derivation for steady flow energy equation. Okay, so steady, you know what is flow was also described. Now we are moving to energy. So if you want to have steady flow energy equation, you are in need of the full knowledge about what is steady, what is flow and what is energies. Okay, so about the energies we have studied all about stored energy and transit energies, and stored about is related to or regarding internal energy, kinetic energy and potential energy. Here you can able to see the equation, no, energy is equal to internal energy, kinetic energy and potential energy. And now you know in detail about kinetic energy, potential energy already you have studied in your schooling. And of course internal energy is the molecular energy possessed by the atoms or the elements, compounds which is present in the working substance. Okay, so for unit mass, when you are writing for specific versions, small e, energy is equal to u plus kinetic energy plus potential energy. And also you we have substituted now the equations for this kinetic energy and potential energy without mass. So that's what here they have given, it is specific. Okay, now next we should also include some of other energies since this is related to flow. Okay, now only I have defined the flow energy. So of course the fluid entering or leaving a control volume possesses an additional energy. Why this additional energy or power is required? To make the flow of the fluid let into or out of the system. So again further elaborated energy, total summation of the energies can be equivalent to flow energy plus internal energy plus kinetic energy and potential energy, where this total energies can be equal to methalpy, the total entering of the flowing fluid. So here again one more thing, you know, already we have defined a property enthalpy. Enthalpy is the summation of internal energy and the flow energy, which was explained in the already videos about if it is the open system means this PV will come into play, or if the you are discussing about the closed system means the PV will become nil. Okay, due to the absence of the flow of the working substance. Okay, then the H would become directly to internal energy. So here we are dealing about open systems and H will play better than U. Okay, so now we are replacing PV plus U by H, then final methalpy will equal to H plus V2, the V squared by 2 plus GZ, that is meant for potential energy. Now again in this slide also I have enriched about what actually the study flow process is. It can the fluid properties can change from point to point, but will remains with respect to time. And here another one more thing which I want to highlight is energy of the total system at the inlet and as well as outlet will remains always change. The system by any movement of the fluid or any changes in the technologies of the device, you cannot change the energy availability. There is no any change in the energy availability at inlet and exit of the system. It is not at all possible. So energy remains same. Okay, so here energy remains same. Okay, at the control volume where you are concentrating. Okay, here E1 is equal to E2. Okay, no properties change at the boundaries with respect to time, and the fluid properties at the inlet and the exit will remain same during the whole process. After this process has been started, whatever the mass which is coming inside the passage will be going out. Whatever the energy is available in the that is inlet will be equal to outlet. Okay, the heat and the work interactions between the steady flow system and its surrounding do not change with respect to time. Okay, so cyclic integral of del Q is equal to cyclic integral of del W, that is the energy E1 equal to E2. Now we are coming to after the descriptions for various energies present or that can be enter or crossing the boundaries of an boundary or the control surface of an control volume. Now we are moving to the next stage of steady flow process or steady flow energy equation is mass conservation equation and energy conservation equation. So conservation of mass principle tells that m dot in rate of mass flow at the inlet minus rate of mass flow at the outlet is equal to dm by dt. Okay, which has been previously told you that conservation of mass principle is of course essentially followed in the control volume. And here you can able to see dm by dt is equal to 0, that is it will not change, that mass containment will not be changed with respect to time. So conservation of mass principle tells the total amount of mass entering a control volume is equal to total amount of mass leaving the system. So here you can able to see in the picture dm by dt is equal to 0. There is no any change of mass, there is no any change of energy. That is, there is no any change of energies means one form of energy has been converted to another form. Already I explained you with the clouds, rains and water in the lake, right? You just remind the energy forms would be changing between this inlet and outlet, but there cannot be any supplementation or reduction of energy since there is no any other sources which unless otherwise you supply any resources. Okay, and now again here energy of the system, total system contains same during the process, and finally we can get the equation of rate of net energy transfer in by heat, work and any type of mass is equal to rate of net energy transfer out of the system by the supplementation of heat, work and mass. Okay, so E dot in, that is rate of energy supplied in is equal to rate of energy out. So finally we are coming to the general steady flow equation. Let me explain one by one. Q dot in, this is the heat supply at the inlet. Here this is the work supplied during the at the inlet, and here the summation of all types of energies like enthalpy, potential and kinetic energy and potential energy is equal to energy out, total energy out. This is for energy balance. Okay, and when you want to find out the exact difference between this inlet and outlet, what happens would be evaluated by the equation by q dot minus w dot will be equal to energies at the exit minus energies at the inlet. Okay, so this equation is called steady flow energy equation per unit mass. Okay, same equation could be written in terms of steady flow energy equation with respect to unit time if you are supplying more than one form of masses. Okay, then it would be easy, or it can be analyzed with respect to SFEE per unit. But usually in all sort of calculations for your syllabus is concerned, better to use the steady flow energy equation per unit mass. Okay, so try to learn this. This is the heart of this unit by which this equation is going to be applied to all sort of thermal devices which are using heat as a input and work as a output. It is very easy to know where del Q minus del W is equal to dE. Already we studied in the first law equation used they applied for a process, right? So this is the expanded version of first law only. Okay, so thanks for patient listening. Let me continue in the next video. This is Dr. Suja. Thank you.